Hello and welcome back. Up to this point, we've been discussing various methods on the fluent-data library. In particular, we've been tackling the dataset object. Before we move on to the next object, which is the matrix class, I thought we'd talk about some of the statistical objects available on the dataset class. We're going to talk about how you can standardize variables, you can do a multiple regression, or you can reduce the number of dimensions. That's like a principal components analysis or a factor analysis. As before, we're going to take our purchases data set and work with it. Let's just do an first output as a baseline. And let's work with standardize. Standardize, you can put in an object similar to when you're reducing, and you can standardize based off of properties of that object. So for example, we can standardize time. Standardize rating. You're wrong. To make it a function, huh? Here we go. Now our time and rating are z-scores. You would do it this way, in particular, if you wanted to standardize not a property directly, but maybe a calculation of an object, a pre-calculation first and then the standardization. Otherwise, a better feature for you might be to use the CSV syntax. For the second parameter, if you wanted, the default is false, which means it's sort of considering that it's working with population data. If you wanted it to assume sample data, set it to true. By the way, I noticed before my my pre-calculated standardization of rating, when I multiplied by 2 didn't change the results. I realized why that was. Doesn't make a difference. You want to regress? You can take your lessons learned from standardization. Oh, I'll backtrack for a second. Notice that in the data set, you didn't just get time and rating when you input it. You got all your data. It just standardized time and rating. All right, let's move on to regress. And let's regress with independent variables time and price. There's your CSV syntax. It used to have the object syntax and whether standardization before. Ran into a hitch, so I backtracked that. I may reintroduce it in the future. It's just not available right now. There's a dependent variable. Let's do rating. And then you can leave it at that, but there you can put in options. And one of them is CI for confidence interval. We're going to do 0.95. The default is actually not any number. The default is undefined, and what you get for that when it returns is a function. So you can do a confidence interval afterwards on the appropriate data. I think I left it at that. I'm going to consult the wiki a little bit just to make sure I don't screw things up. Oh, I think I did use an attach data true. So the default is that you won't get a returned data set with estimates. But if you set it to true, you'll get that in the return object. I think there's another one. I'm going to leave it alone because I don't remember it. But I think there's a min digits, but I'm going to leave it out for this. When I log, I already know the results are going to be very long values, so I'm going to round it right away. I already know I need to do that. Oh, and I also, actually, before I run that, let's put it into a variable. The reason we're going to do that, we could log it right away, but it won't log the data that we want returned. Now, when you log on a regressed object, you're not getting a data set. Let's simplify this a bit. You are actually getting a more complex object, but it has a log and it works the same way. Let's actually not do it to negative. Let's do -6. And then let's do a caption because we're going to log two things. We're also going to log the data object on the return. That is a data set, so you can just do the same. I'm going to give it a little space from before. Let's run that. Beautiful. We've got our intercept, time and price, the values, standard errors, p-values, confidence, the resulting confidence intervals. You've got in your model object, you've got your r squared and it's adjusted, p-value, test for whether it's got equal skedasticity, whether it's the variance is consistent throughout. And you've got your data. It's the same data set with some properties attached. You got your estimate, you got the actual score, and you got your residual. Let's look at a dimension reduction. So for dim reduce, we want, let's do all our numerics. I do recall in the wiki that I did some options. I think I want to repeat that. Oh, the min eigenvalue. Good call for checking that. Default is 1. I'm going to put 0.25 because I know with the data set I'm working with, it's going to only reduce to 1 dimension unless I put this really low for 2, just for this discussion right now, not because we would actually do that. If I were to really work on this in the future, I won't really emphasize the min eigenvalue. I'll try and do some sort of test for that elbow, but in that scree plot. But I'm right now I'm just following standards and going with min eigenvalue. You can return data on that one as well. I'm not going to right now. From what I recall in the wiki, I chose a really small value. I don't even remember why, but dimension reductions are touchy like that. And there you go. You got your books, time, price, and rating against your created dimension 0 and dimension 1. There's your correlations for the rotated plot, communalities, specific variances, proportion variances, some squares as appropriate. There's your unrotated matrix. There's your original eigenvalues. And then there's your correlations before you get started. It sort of works in reverse order here. You get your last result first. These won't be the only things available in the future. You'll see it evolve. You'll see the functionality within these things evolve. They are based on, I would go on mathematical articles available on Google Scholar and other areas. When building these things, I have since learned there are stronger libraries already existing that might be able to be ported over. But so maybe they'll become more rigorous in the future. Plenty of room for growth on these statistical methods. And so expect growth in the future, but here's where the library is at, and I'm pretty proud of it, and I hope that it's very useful for you guys out there as well. In the next video, we'll discuss matrices.